Did you ever discover you could do a cool new trick? Or have you ever asked a friend to double check your essay for mistakes? Well, scientists love to discover cool new things, write about them, and then have their peers double check their work for mistakes too. That's the nature of scientific research. Scientific research is the systematic investigation of scientific theories and hypotheses. By the way, just in case you didn't already know, a hypothesis is a single assertion, a proposed explanation of something based on available knowledge, for something yet to be explained, one that is subject to further experimentation. In science, the people who create such hypotheses are researchers. Most researchers work for companies or academic institutions. Many of them, but not all, have a PhD in an appropriate field related to their research. For example, a person conducting research on a new drug may have a PhD in chemistry. A PhD in history probably wouldn't do much good. Anyways, scientific researchers try to answer the many questions we have about how the world works, but a lot of their work doesn't really have to do with the questions at the forefront of our minds. I mean, yes, we're all fascinated with knowing whether or not there may be life on other planets, but for many reasons, such research isn't as common as finding out whether or not a drug you never heard of has a potentially dangerous side effect. We may not think about this kind of research very often, but it impacts us or people we know far more so than search for life on other planets. Until, of course, we do find out we're not alone in this universe and are potentially going to be invaded by little green men. Furthermore, scientists don't just come up with explanations about the world around us willy-nilly. Not even close. Scientists use the scientific method, a process that helps construct an accurate depiction of our universe and its processes, in order to answer whatever question they may have. What this means is, researchers observe the world around them, formulate potential explanations for the phenomena they observe, test their hypotheses out with experiments, and analyze their results to see if they were right or wrong. The key thing about the scientific method is that it carries no prejudice, meaning you don't even have to believe whatever it is the researcher wrote or said. Using the scientific method, you can repeat the experiment to find out for yourself whether or not the other researchers' assertions are true. This is a key factor that separates science from dogma. The other important part of scientific research is that a hypothesis must be falsifiable. A falsifiable hypothesis or theory is one where an experiment or another discovery can prove it to be wrong, untrue, and false. This is another critical factor that separates science from the world of religion, astrology, and pseudoscience. If I were to say that Bigfoot exists, but always hides when humans are around and leaves no evidence behind, that, in the words of Penn and Teller, is Bologna. There is no way to disprove such a statement, and it is therefore unscientific. Overall, scientific research helps people come up with rational, objective, testable, and disprovable questions and methods that help us explain the world and its ever-changing nature. In science, you don't have to believe anything. You are free to test it out for yourself and prove or disprove anything you want in an objective and unbiased manner. Even though scientific experiments are constructed and conducted in an objective and unbiased manner, science provides for two more fail-safes to ward off potential mistakes in the evidence collected and conclusions reached after an experiment. One of these is the peer review process. Peer review is a process where scientific experts not connected to the study and experiment in question check it for scientific accuracy, proper methodology, and relevancy before the study is published in a scientific journal. What this is saying is that the final paper written about a hypothesis, the experiment, and analysis thereof is checked by scientific peers. It's like having your essay checked by a friend. Peer review helps scientists catch mistakes and ward off questionable data. Another tool in the arsenal of scientific research is math. Researchers use math to figure out if their findings are statistically significant. If a finding is statistically significant, then it was unlikely to have occurred due to chance alone. For example, you may have heard that certain areas or even towns in this country have a lot of people who get cancer, more so than the rest of the nation. But did you know that such clusters of high numbers of cancer cases can actually occur completely due to chance and not as a result of something like bad water, chemicals in the soil, and whatnot? It's completely true. The only way to find out if it is actually due to random chance or not is to conduct an experiment and analyze it scientifically. A scientific research is the systematic investigation of scientific theories and hypotheses. A hypothesis is a single assertion, a proposed explanation of something based on available knowledge for something yet to be explained, one that is subject to further experimentation. Scientists use the scientific method, a process that helps construct an accurate depiction of our universe and its processes, in order to answer whatever questions they may have. Such a method allows scientists to construct questions about observed phenomena, construct experiments, and analyze results. In addition to the scientific method, researchers depend on the peer review process. Peer review is a process where scientific experts not connected to the study and experiment in question check it for scientific accuracy, proper methodology, and relevancy before the study is published in a scientific journal. Researchers also use mathematics to determine if their findings are statistically significant. If a finding is statistically significant, then it was unlikely to have occurred due to chance alone.